Okay, synthetic division is going to use the coefficients from your polynomial and the 0 from the factor that's given to you. So what would the 0 be for x minus 2? If we have x minus 2 equals 0, then the 0 is actually 2. It's also called the root. You want to use the root. You don't want to use the actual negative 2 in this. All right, so the root here is 2. All right, what are the coefficients of your polynomial? We get a 1x to the third, 5, a negative 7, and a positive 2. I'm just looking at the numbers in front. I'm going to write them out. Now, I probably should have used an example where I needed to put a 0 in, but just promise me that if one of these terms is missing, you start with 3 and you need a 3, 2, 1, and then a 0. And if one of those are missing, you put a 0 for the coefficient. All right, here's how it works. You write the coefficients out. 1, 5, negative 7, and 2. Then you put your root in front. Okay? Then it's a matter, you draw a little box here. This is the same process every time. We're going to bring a number down, and it's multiply, and then add. All right, multiply, so it's 2 times 7, which is 14, and now add. So negative 7 plus 14 is a positive 7. Multiply, 2 times 7 is 14, and now add. You get a 16. All right. I don't know if you're ready to be impressed, but you better buckle down because check this out. Booyah! Here's the answer from the last problem that we got. Let's put it down here. Let's look at our answer for both of these. This is x squared, or a 1x squared, plus 7x plus 7. 1x squared plus 7x plus 7. The remainder was 16. The remainder is 16. So the numbers you get here are the coefficients of your answer. This is crazy. So how do we take and write our answer from the synthetic division problem? It would be that. First of all, you got to understand that would be the remainder. All right, and then we have 1, 2, 3 terms, so that's got to be quadratic. So it goes x squared. This is your x term. This is your regular constant. So it's 1x squared plus 7x plus 7, and then go back here. You're dividing by x minus 2. So it's plus 16 over x minus 2. Don't go back to your positive 2 because that's not correct. It goes back to what you're dividing by, your divisor. And that's your answer. How much easier was that? That was incredibly easy. That was crazy easy. Crazy delicious. Let's look at F, otherwise known as the grade Brust saw most often in college. Anyways, determine if x plus 3 is a factor of big ugly polynomial. Is this a factor of? Well, we have to really understand what that means. What does it mean to be a factor of a polynomial? Well, let's take regular numbers here. All right, let's try like 100. Is 8 a factor of 100? That's the question I'm going to pose to you so we can understand what factor means. Well, let's divide 100 by 8 and see what we get. All right, so goes in one times 8, goes in there, goes in 2 times, multiply through, you get 16, remainder 4. Okay, so it's 12 and 4/8, otherwise known as 12.5. No, it's not a factor. Why? Because when I divided, there was a remainder. I want numbers that go in perfectly. Let's try 5 instead. You guys know where this is going. All right, so when I put a 5 in, I get 2 times 5. Oh, that looks nice. 0, bring down another 0, goes in 0 times. Everybody's happy. Look at the 0 at the end for the remainder. So 5 is a factor. So how do we check if something's a factor? Well, you can just divide it out and see if you get a remainder equal to 0. That's the part that we're going to focus on. So I want to divide this polynomial by this factor or this binomial to see if it's a factor. Is that a factor? Let's use synthetic division. We're going to write down our coefficients. Here we go. We have a 2, a 1, a negative 8, and a 21. And remember, we put the 0 or the root. So this is x plus 3. If you need to, you don't figure it out over here. When will this equal 0? X equals negative 3. All right, negative 3 goes out front. And then you draw your little box. And remember, bring the first number down. So, negative 3 times 2, negative 6. Add, we get negative 5. Multiply, negative 3 times negative 5 is positive 15. Add, whew, that's crazy, we get a 7. Okay, negative 3 times 7 is negative 21. Add 0. If you remember what we did before, that last coefficient here, this last number, that is your remainder. We have a remainder of 0. So what does that mean? That means that the trinomial 2x squared minus 5x plus 7 is the resultant quotient when you divide by x plus 3. So that means that x plus 3 times 2x squared minus 5x plus 7 will yield you this polynomial after you multiply. But it wants you to also find the other factors. Well, the good thing is this is a quadratic equation, and you know what? I can probably factor this. I know how to factor that. How does that factor? I'm going to do it old school way. All right, so 2x and a positive x, and then we're going to need, how do you get a positive 7? You know, you could do the little magic x here, a 14 and negative 5. You're not going to find anything. Long story short, this does not factor anymore. So it says find the other factors. The other factor is 2x squared minus 5x plus 7. The answer to the question, determine if it is a factor. Yes, it is a factor because that last remainder was 0. Now, this brings me to two new theorems, but they're not new. They're just kind of, becoming enlightened to us. Can I say that? I don't know, but you remember back when we did synthetic substitution? Remember that? And lastly, when we add, we get positive 9. So we know that t of negative 1 equals 9. Wow, that guy just sounds handsome. I don't know about you, but that's what I think. Anyways, so we could evaluate a function using synthetic substitution. That's really what we did here, right? I mean, you've seen this before. The only thing is, when we plug in the number here, t of negative 3, that's why we wanted the 0. We want to know the value at x equals negative 3. We plug it in. If we get a 0 for the remainder, that means that f of negative 3 equals 0. What? So, how can we generalize this? If a polynomial is divided by x minus k, then the remainder is whatever you get when you plug in positive k. Okay, so that's because of synthetic substitution. But more importantly, the factor theorem says the polynomial has a factor of x minus k if and only if f of k equals 0. And so that brings us right back to this right here. If you plug in, we're using synthetic substitution, you plug in the negative 3 because at x equals negative 3, you get 0 for a remainder. That means that is a factor. That is a big idea here. You have to kind of understand that. So you're looking for, when you plug in the value, a 0 for the remainder, and that's what the factor theorem says. Now, we're going to have to be able to go between zeros, roots, and factors seamlessly. You got to go back and forth. Interchange them. Remember, the zeros and roots are the same. A factor is an expression. So x plus 9 is a factor that will lead to 2 zeros or 1 0 or whatever. So suppose you already know that x plus 9 is a factor of this function. Okay? They want you to factor it completely. So pause the video. You should be able to do this one. New problem now. Go! Pause the video. Okay, hopefully you got this far. You put the root out front, the 0, and then what do we have here with a polynomial? Bring down the 1, multiply, add. You get a remainder of 0. So we know that x plus 9 is one factor. That was given to us. And now we know that if that's the 0, or if that's the remainder, we have x squared minus 7x plus 12. That is another factor, but we need to check to see if this will factor again. So I'm going to check it out. X and x. We need to get a positive 12, but a negative 7. I think a negative 4 and a negative 3 will lead us to that. Let's double check it. You get a negative 4x and a negative 3x. That gives us a negative 7x multiplied to positive 12. We can't forget the first factor that was given to us. There we go. We just factored that completely. So you might have asked earlier, when are we ever going to need this? Well, it is important to know where the factors of polynomial functions are. And with synthetic division, you can actually get another factor that may be factorable, and that can help you find the zeros and the roots. All right. Suppose you know that x equals 2 is a 0 of the function x cubed plus 2x squared minus 9x minus 18. Find the other zeros. Ready? Go! That's for you. Pause the video. Go! Okay, before we begin, let's watch another little bit of the Big Bang Theory.
Okay, glasses off. Find Waldo.
Hurry up, find him, find him.
I'm trying, don't yell at me.
For goodness sake, he's wearing a hat, glasses, and a red striped shirt.
I know what he looks like.
Oh, there he is, I got him. Yes! Oh, we win again!
How could you not find him?
Because he's hard to find. If he was easy to find, the books would be called There's Waldo.
So the question really is, who are these people? And the answer, of course, Mr. Bean's students looking for him on flipmath.com. All right, so we go through synthetic division. We get to this part, 1, 0, negative 9. What does this mean? This means that the first root was given to us, or the first 0. Okay, that means that the factor must have been x plus 2. And then after we figure it out with synthetic division, we get x squared plus 0x. So I'm not going to write that down. We get minus 9. All right, so this x squared minus 9, that's a difference of perfect squares. So that's going to give us x plus 3 and x minus 3. All right, well, guess what? Find the zeros. Okay, it all equals 0. So we're going to get x equals negative 2. We knew that because they gave it to us. X equals a negative 3 and x equals positive 3. Okay, set each one of these equal to 0. And we're done.